everything must be shown. It will be like a test grade. I will be checking each and every single problem. And it will be right from the miscellaneous or from any part here. Remember, I will need your input here. And these are the type of problem I will be giving you. Okay? And I'll be showing you how is it that we do basic arrangement to minimize these type of problem, so that you don't need to be writing out or listing all the combination, whereby we tend to use combination and permutation when we look at arrangements. Number 5 is saying mass-produced glass bricks are inspected for defects. The probability that a brick has air bubble is 0.002. If a brick has air bubble, the probability that it is also cracked is 0.5, while the probability that a brick free of air bubbles is cracked is 0.005. What is the probability that a brick chosen at random is cracked? The probability that a brick is discolored is 0.006. Given that discoloration occurs independently of the other two defects, find the probability that a brick chosen at random has no defects. So this comes from Oxford and Cambridge, from an examination board. Oxford and Cambridge. So let me see how good your brains will be working. So what's the first thing that we need to do here? Student, I'm asking a question. What's the first thing we need to do?
Define our events, sir.
Okay, we need to define our events. So we can mention about they have talk. What are the events that we have here? List them before we write them down. What are they?
The brick has air bubbles, sir.
Okay, air bubbles will be one. So we can use a capital A to represent the brick that has air bubbles. So the one that will not be having air bubbles will be a complement, right? So that's the first one. So what will be the second event that we need to list or to write out?
The probability that the brick is discolored.
Yes, that will be one. That will be the last one we should, but there's one more before that.
The brick is cracked.
That the brick is cracked. Okay, so we are looking at air bubbles, cracked, and at the end we will be actually tying discoloration along to this problem. So we're gonna be looking at A, be the event. A brick has air bubbles. And then we mentioned that we're gonna be using C to indicate that the brick is cracked. The event that the brick is cracked. And then we can use D for discoloration, or a brick is discolored. Okay. Now see what other information that we can gather from here. Let's see what other information. So let's start writing down some info here. They mentioned that, let's go back to the problem. Mass produced that brick are inspected for defects. The probability that a brick has air bubble is 0.002. So that would be the probability of A would be equals to 0.002. So which means then the probability of a brick that do not has an air that do not have air bubbles all this we could put in right away because we're gonna be needing them. So the probability that the brick does not have a bubble will be what?
0.005.
Why 0.005? Remember, the probability of a brick has a bubble is 0.002. And remember, the complement and its event itself add up to 1. So in order for us to get the complement, we need to subtract 0.002 from 1. And that will give us, I think, 0.998. Right? Is that so?
Yes, sir.
Now, Then we go back and we see what's happening here. It then say that if a brick has air bubbles, if a brick, that's the condition being given, if a brick has air bubbles, the probability that it is also cracked is 0.5. So how would we write that? Using the notation that we have.
Sir, wouldn't it be an intersection, sir?
A what? I
An
just
intersection?
mentioned that is conditional probability. And because it gives you a condition. It said there that if a brick has a bubble, it's already telling you that the brick, that's the condition, that the brick has air bubbles. The probability that it is also cracked is 0.5. So what would we do there? That would be the probability. We already used the notation for crack, which is okay. So the probability that it is also cracked given that a brick has air bubble like that. It's telling you that it has air bubble and it is also cracked. So that will be equals to, oh, they give a value for this.
Sir, isn't Shanti right? You're gonna do an intersection like C intersecting A, and then you're gonna divide it by the probability of A?
Yeah, but then we already got this value already though. Yeah, we already got this. It's there, which is 0.5. Right? So we don't need to go and solve it, but that would have been the correct formula to have solved it, but then they gave us that probability, which is 0.5. Then they gave us another
Sir,
thing
is it
there.
0.5, sir, or 0.005?
Let me recheck. I think it's 0.5. It said if a brick has
Yes,
air
sir.
bubbles, the probability that it is also cracked is 0.5. While the probability that a brick free of air bubbles is cracked is that. So what would be the notation for this one here? So it's gonna be the probability that it is cracked given that it doesn't have air bubble. Now this one is 0.005. Okay. And we're gonna leave the one for discoloration. Let me just put that in the other. So that it is discolored. So let's see that the probability that it is discolored. What was the probability that it is discolored?
0.006, sir.
Okay, 0.006. Okay, so that's information being given to us. Now, the first thing that they are asking, the problem is asking here, what is the probability that a brick chosen at random is cracked? Okay, so they want the probability that it is chosen is cracked. So what would be the formula for that? It tells you it is cracked. So the probability that it is, that a brick chosen is cracked. Now, that will be equals to the probability, remember the special results, of C of C of C intersecting A plus the probability of C intersecting, and then we go here A complement. Okay, like that. Now, from what we got, how can we find C intersecting A?
Reducing the formula, sir.
Okay, which formula are we gonna be using? Looking at the information that we got, what would be a formula that we can use?
Sir, wouldn't it be A times C, sir?
But why A times C?
Sir,
Remember, there's an intersection. The brick could be cracked and has air bubbles in it. So that's what we are talking about.
sir, the probability that it is cracked and it has a brick has air bubbles where you have the A complement, which is equal to 0.05.
So let's find C intersecting A first. Then we need to find C intersecting A complement. How are we gonna find C intersecting A? So how are we gonna find C intersecting A?
Sir, it will be C intersecting A times the probability of A
Yep, yep. But let's write the proper formula, then we go into that one. That is correct. So what would be up here then? The probability of?
C intersecting A.
Okay. Over the probability of
A.
A. Okay. So like what you said, we can have the following. That the probability of C intersecting A will be equals to the probability of C given A times the probability of A. Just like what you rightly said a while ago. So let's find that. Copy and paste. Okay, the probability of T given A is 0.5. That was given. So that will be 0.5. And then the probability of A is 0.002. So how much will that be? So what will be the product there? Student, what will be the product there?
One over 1,000, sir.
I want it in decimals. And that will give an exact decimals.
0.001.
0.001, you say?
Yes, sir.
Yes, sir.
Like that. People compare your calculator. Is that right? 0.01?
Yes, sir.
Yes, sir.
Okay. Now, we need to find C intersecting A complement. And that can be done using this here. Okay? Because we want to find C intersecting A complement. So let me just have it because it's gonna be something similar to this here. I just gonna be changing some stuff. Okay. So this will be C given a complement So this would be C intersecting a complement over the probability of a complement. So the probability of C intersecting a complement is equals to the probability of C given a complement and the probability of a complement. Now, we have C given a complement, which was, let me go and see. Zero 0.005. And the probability of a complement, which was okay. So when we multiply this, what do we get?
Zero point zero zero four nine nine.
0.0
Zero 499.
499. Okay. So now to complete what we want, all we need to do is the following: insert. That's the probability that it is correct. Remember, I already gave you the formula from the beginning. Is equals to, because remember, this was the formula here. The probability of C is equal to the probability of C intersecting A plus the probability of C intersecting A complement. So we have found C intersecting A, and also we have found C intersecting A complement. So all we need to do is to add those two together, and that will give us our answer. So that will be 0.001 plus 0.00499. So what will that give us?
0.00599.
You sure of that?
Yes, sir. He's right.
Yes,
0
sir.
point.
0.059.
Right now. They're gonna be 0 point 0. What will it be? 0.01? I'm waiting for the rest of the
Another zero,
digits.
sir. Another 0.
Uh-huh.
599.
Okay. So that will be the probability that it is cracked. Any questions? Any questions?
Not so far, sir. No question.
Okay, that's just the first part of the question. Now, given that discoloration occurs independently of the two, find the probability that a brick chosen at random has no defect. Has no defect. Has no defect meaning then what? A brick has no defect. Now, in order for a brick to have no defect, then what will that be? Let us put that the probability of E. We are mentioning that let E be the event that it has no defect. So if a block doesn't have any defect, which means then that the probability that it has no air bubbles, and they are independent, times the probability that it is not cracked times the probability that it is not what? The probability that it is not what? Student, are you hearing me?
Yes, sir.
Yes, sir.
I'm asking for something.
It is air something, sir. Air bubble.
The first one is air bubble, that it doesn't, it said that the brick has no defect. Remember, there were 3 defects. Previously, there were 2, air bubbles and crack. And then they've mentioned one further, discoloration.
That the
So,
brick is not cracked, sir?
yeah, because it said that it has no defect. It said here that the probability that a brick is discolored is 0.006. Given that discoloration occurs independently of the other two defects, find the probability that a brick chosen at random has no defect. So no defect meaning then that it doesn't have any air bubbles, it isn't cracked, and it isn't discolored. Are you getting the picture?
Yes, sir.
Yes, sir.
Okay. So that it has no air bubbles, it has no crack, and it has no discoloration. So a complement was, let's go back and see what a complement was. 0.998. Zero 0.998. That it is not cracked. That it is not cracked. So we found that it is cracked here, down here. Where is it? Yes, 0.00599. Subtract that from 1. So take 1, subtract it, subtract 0.00599 from 1 and give me that value. What will it be?
0.994.
0. Give me a break here. No. Okay, class. So which means then that this will be 0. What? Remember I told you to have subtract 0.00599 from 1.
Sir, I got 0.99401.
9.
401.
Yes, I got that too, sir.
401, sir.
Exact?
Yes, sir.
Okay. And then that it is not discolored. We have that for it to be discolored, this is to be discolored 0.006, but not to be discolored, what will it be? Subtract this from 1.
0.994.
Okay. Let me put that in. 0.99.
94.
Okay, multiply all of this together.
0.987.
So the probability equals to what?
0.987, sir.
0. See, I forget the value.
987.
Okay, 987.
I get 0.986.
Yes,
Exact.
sir, that 0.986. Well, it's a long number, sir. We're just rounding it up.
Okay,
Yes,
then.
because then the after number is 0. After 6 is 0, so it's 0.986. Katie had something wrong.
Okay.
I got 0.986, sir, but then I rounded off.
But then
But what
Since the
comes
next
after the
number
6?
behind it is 6.
0.986.
0 goes after the 6, sir.
And 8.
Okay. One says an 8. One check.
No, sir, it's a 0. It's a 0, sir. It's 0.98606.
Yes, sir, I got that too.
Okay, so it will be this way you're talking about.
Yes.
And that will be to 3 significant figures. Okay. So that problem is finished there. Are there any questions based on it?
No, sir.
No, sir.
So this is the miscellaneous one, sir?
Yeah. Even we are not yet, this is an exam, it's miscellaneous because it came from an examination board. This is made from Oxford and Cambridge University, or O&C. So it's telling you that anything that has something at the end is an examination question. So this comes from an advanced A-level question, which is or Oxford and Cambridge. Right? But all of them are easy when you look at it. You just have to know your notation and what you need to use. You understand? Since there are no other questions, it's already...
Excuse me.
Yes.
For C complement, I got 0.99501. That's why at the end I got 0.987.
For C complement, what you got?
0.99501.
It's mentioned that C was, let me go and check. So it will be, let me check this. I didn't want to hollow my calculator, but I need to. So it's gonna be 1 minus 0.00599. So you get 0.99401. That's correct. Okay, remember you are subtracting it from 1. So 0.99401 is is correct. And then that will be times 0.998.
Okay, sir, I see my mistake. Sorry.
Okay.
I was just confused about something, but I see now. Thank you.
Okay, you're welcome. Okay. That's it. It's correct. So we're gonna end there for today. Enjoy the rest of the day.
Thank you, sir.
Okay.
Thank you, sir. Thank you.
Remember,
Bye.
there were some people that came in late and they didn't even ask me about putting down their names because I already took attendance, and then